Okay, we're still 1.6, absolute values. Now, I don't know if you ever thought about this, but absolute values are really weird, right? They're the one thing in math, like type of function in math, that is one of the most peculiar. It's not hard, right? Right? Like if you know, absolute value of 7 is 7, the absolute value of negative 7, is 7, right? It's not hard, but what's weird about it, and this is the thing, what you have to do is you have to look at what that number is. Is it what's inside the absolute value? You actually have to look at that number and then you decide what you're going to do, which is weird. Like when you multiply, you don't do that, right? You don't look at the number. You just, if it says multiply by 7, you multiply by 7. You don't care what the original number was. Same with division or squaring or square rooting. Well, I guess square root you have to kind of look to see if it's negative because you don't want to do that. But in general, what's weird. Absolute values are not hard. They're peculiar in that what you do is dependent on whether the number inside the absolute value is inherently positive or negative, right? You either do nothing or you do the opposite, which is weird, right? So just be aware of that. That's something that you have to be aware of. Now, here's the thing. What if you have absolute values in these things? What happens? Okay, so let's look at this question here. What's the limit from the left, limit from the right, and limit? So it's kind of similar to what we did yesterday. This leads to something called piecewise function, which we're going to spend some time on later. Well, not fun, and functions. Because here's the thing. Absolute value itself, let me put x here, is in actually two different pieces, right? Because the absolute value, this is negative x, and this is positive x. When x is bigger than equals 0, or when x is less than 0, right? Let me just tilt that just a tad. There we go. So it actually has two pieces, right? It has two different pieces, in a sense. What we want to do, and this is kind of like, it's going to be negative x, and then it's going to be positive x when x is, when it's bigger than 0 or less than 0. So that's just something to be aware of, is that it's really two different pieces. So like the absolute value of x minus 3, that's just the v shifted back 3, right? So what we want to do is, let's stop and think what's happening here. Now I'm going to do it two ways. I'm going to do it intuitively, and then I'm going to do it mathematically, okay? They're both mathematical, but one's using algebra, and the other's just kind of using common sense. Common sense. And I'm not saying common sense is not a bad approach, okay? It's not a bad approach, but I do want to show you the algebraic way of doing this as well. Common sense. Something divided by itself is 1. So what I know is these got to be 1s. But then again, we have to use common sense. Yeah, but remember, these are a bit different, right? This is like 2.99. Remember, I'm taking numbers less than 3. And this one here is like taking numbers that are bigger than 3, right? Those are bigger than 3, right? So what I'm doing is I'm thinking to myself, well, if I take a number less than 3, like 2.99, I'm going to get a negative number of some sort. I don't care what it is. But no, because these numbers are the same, right? Whatever it is, it's the same. But that negative is going to go away because of the absolute value. And a positive divided by a negative is negative, so it's negative 1. So think about it that way, like oh, yeah, something divided by itself is going to be 1, but if I take numbers less than 3, that's going to be negative, and that's going to be positive, and so negative divided by positive is going to give me a positive 1, or a negative 1. Now, if I take numbers bigger than 3, what if I take a number bigger than 3? Well, it's positive, and remember, absolute value of positive is just positive. Positive, so positive 1. So from the left is -1, and from the right is +1, and of course, sadly, these are not the same, so the limit does not exist. The limit does not exist. Okay? Now, that's not the way we're supposed to do it. There's nothing wrong with it. Okay? You can just think it through. Okay? What you're supposed to do is you're supposed to do this. Oh, I shouldn't have erased the actual question. Sorry about that. Hopefully I can remember what it was. Was it x minus 3? What you're supposed to do is you're supposed to break it into its 2 pieces. You got one piece that's less than 3 and one piece that's bigger than 3. Okay? Now, I would do the bottom one first because I think it's easier. Okay. If you pick numbers bigger than 3, so I'm going to do the bottom one first. If I take numbers bigger than 3, the absolute value won't matter. Keep in mind, if I take, every time I do this, numbers bigger than 3. Always bigger than 3. If I take a number bigger than 3 and subtract 3, it's going to be positive, so the absolute value will go away. It's not necessary. I can throw it away. So it's going to be, oh, crap. I said I did the bottom one first. Sorry about that. I mean, just put it in color just to illustrate. In the bottom one, since I'm taking numbers that are already bigger than 3, the absolute value is unnecessary. I can throw it away. I can just get rid of it. So when I take numbers less than 3, bigger than 3, 3.01. Now, what if I take numbers that are less than 3? This is where, the reason I did the bottom one first because it's pretty easy. It's kind of like the 7 idea. It's like, just throw the absolute values away. The negative one means, change the sign of what's in there from -7 to +7. So what happens here? If I take numbers less than 3, if I take numbers less than 3, that's going to be negative. So I want the opposite of that. Now remember, they're always less than 3. So if I take a number that's always less than 3 and subtract 3, if I take a number always less than 3 and subtract 3, it's going to be negative, right? So that means that's a negative number, kind of like a -7. So then what I need to do to get rid of it is kind of like this. I didn't write it this way, but what you're really doing is putting another negative on the -7 to make it +7, right? So put another negative, because this is negative itself, right? Over x minus 3, and the x minus 3's cancel, and you get -1. So we can see this one is -1, and this one is +1. And again, these are not the same, so we say it does not exist. Well, it's like I said 1 there, and that's supposed to be a D. Does not exist. And we can actually graph this real quick if you wanted to. You don't have to, but got our 2 pieces here. Notice that when you are less than 3, it's -1 the whole time. And when you're bigger than 3, it's +1. So that's kind of what the graph would look like. I didn't ask you to graph that, but I probably should have. Anyways, and notice that nobody gets the 3 because you're not allowed to divide by 0, right? So this is it. No, you can kind of go, okay, I get it. It's back to that 0 over 0 thingy again. Yeah, it's the same as the 0 over 0 thingy, but we have absolute values. Okay. How about this one here? This is kind of weird, right? We're going to take a parabola and divide it by an absolute value, right? What do you get when you take a parabola and divide it by an absolute value? Okay, so let's do this by piecewise functions, though. We're not going to do this one intuitively. We'll do it by pieces. So x minus 2 is 1. So when you break it into its 2 pieces, you want to do x is bigger than 2 and x is less than 2. So again, I'm I'm going to take numbers like 1.99, and I'm going to take numbers like 2.01. Okay. So what if I get really close to 2, but I'm always less than 2, or really close to 2 and always bigger than 2? Okay, so I always do the bottom one first. If I'm bigger than 2, if I put a number bigger than 2 in, and I always put a number bigger than 2 in, this is going to always be positive, so I don't need the absolute value. So this just becomes x minus 2, and then you can cancel them. So it just becomes x minus 1. And then on the top one, and again, remember the top one's a little more confusing because it's going to generate the negative. It's not that much more confusing, but notice that if I now put in a number like 1.99, this is now inherently negative. So how we get rid of it is we rewrite it not as x minus 2, but as negative, the opposite of x minus 2. This negative is actually going to, because this is negative is going to actually turn into a positive. So this cancels. So I have x minus 1 divided by negative 1, which makes this negative x plus 1. So now, before we do, I'm going to graph it, but let's do the limits real quick. The limits as x approaches 2 from the left, limit as x approaches 2 from the right, limit as x approaches 2. Okay, so f of x. So if I put 2 into the red one, like the 1.99 one, negative 2 plus 1 is negative 1. And then if I put 2 into the, I get positive 1. Oh crap, positive 1. And again, as you probably realized, those are not the same. Sad face does not exist. And then now if you want to graph them, what you do is you got to make little t-charts, I guess. You got x and then negative x plus 1. I'm going to put 2. Remember, the number's less than 2. Now you're probably thinking, Mr. Peters, you can't put the 2 in. You can. You got to just relax, okay? So if I put the 2 in, I got the negative 1. If I put the 1 in, I get 0, negative 1. Now, I will admit this. You got to be a little bit careful when you go doing your graphing here. 2, negative 1. You do have to leave it open. Because you're right, you can't actually put 2 in there. But then I get 1, 0, and then 0, negative, no, 0, 1. Sorry, we put 0 plus 1 is 0, 1. So there's this line. Now these are the numbers that are less than 2. So there's the 2. X is less than 2. There's the equation for that one. And then this one here, do a little t-chart for x and x minus 1. You put 2 in and you get 1. You put, don't put 1 in. Whoa, we need numbers bigger than 2. So I'm going to pick 3 and 4. 3 minus 2 is 2, 3. So I get 2, 2, 1. It has to be open because you can't actually put the 2 in, right? That's called the limit though, right? So we have the limit, but not the actual function value. And then 3, 4. Now it's just 2 words all broken up. So that's kind of weird. So that's kind of weird, right? When you're doing this, you get, when you take a parabola and divide it by an absolute value, you get 2 line segments that are broken apart. In case you ever wondered.